The same steps used for solving equations that we learned in our previous lessons can be applied to solving inequalities with one distinct change. When multiplying or dividing both sides of an inequality by a negative number, the direction of the inequality symbol must be reversed. Let's take a look at why. True or false, 3 is less than 4. We know this to be true. Let's apply our addition principle to this. If we add 2 to both sides of our inequality, then we end up with 5 is less than 6, which is still true. Therefore, our addition principle does not change. Let's begin with 3 is less than 4 again. And this time, to each side of the equation, we will multiply both sides by a 2, which note 2 is a positive number. After multiplying both sides, we end up with 6 is less than 8, which again remains true. Therefore, multiplying both sides of an equation by a positive number is the same as it was in our solving equation steps. However, this time once we start with 3 is less than 4, and we multiply both sides by a negative 2, we end up with negative 6 is less than negative 8. But examine that inequality. Negative 6 less than negative 8. We know that that is actually false. Negative 6 is greater than negative 8. And it is for that reason that when we multiply both sides of our equation by a negative number, our sign must flip. Let's take a look at what the rule actually states. The addition property for inequalities, as I had said before, nothing changes. If A is less than B, then you can add C to both sides, and the inequality symbol remains the same. However, the multiplication property has a slight adjustment. For any real numbers A, B, and C, if C is greater than 0, in other words, if you're multiplying by a positive number, then A less than B is equivalent to AC is less than BC. In other words, you can multiply both sides by a positive number and the inequality symbol remains the same. However, when you're multiplying by a value that is less than 0, a negative number, then A is less than B is equivalent to the symbol AC is greater than BC. And take important note to how our symbols flip from less than to greater than. This will always be true when multiplying or dividing by a negative number. Let's practice. For example 1, for each one of these, let's solve the inequality and then graph the solutions on the number line. For number 1, we want to isolate our variable, so we will use our addition principle, and we remember that our addition principle is the same with inequalities as it is with equations. Subtract 10 from both sides, so x is greater than negative 16. We do not need to flip the sign because the addition principle doesn't require that. Now let's graph it. We put negative 16 in the middle of our number line. We put negative 15, negative 14. We could also put negative 17, negative 18 on the other side. And when we graph x is greater than negative 16, we do an open circle at 16 and shade all the area to the right. Let's look at example 2. This time we again isolate our variable a using the addition principle, adding 5 to both sides. So a is less than or equal to 1. And note, we always read inequalities beginning with the variable. Don't say 1 is greater than or equal to a. say A is less than or equal to 1. And we could even rewrite this, A is less than or equal to 1. They are equivalent. Let's graph that. A, let's make our number line of 1, 2, 3, 4, 0, -1, -2. This time put a closed circle at our 1 and shade all of the values less than 1, because these are our solutions. Example 3, here we want to solve for n, and we will multiply both sides of the equation by a 3/2, which is the reciprocal of 2/3. The important thing to remember here is that we're multiplying by a positive number. So when we use the multiplication principle and multiply or divide by a positive number, this time 3/2, our sign does not flip. It remains in the same direction, this time less than. When we cancel and multiply, we get n is less than 12, and we can graph that on our number line. Since it's less than, we do an open circle, and then we shade all the values left of the -12. Finally, we get to example 4. In this example, to isolate our variable y, we have to use the multiplication, and we need to divide by a -5. Here is our first example of dividing each side of the equation by a negative number. Since we used the multiplication property with a negative number where we're dividing by both sides by a negative, we end up with y, and we need to, as we indicated on our last slide, flip the sign to say now y is greater than or equal to the answer -8. Now we can graph this one on our number line. Here we will draw a closed circle at -8 because of the greater than or equal to symbol, and shade all the values greater than -8, as these are our solutions.